Good day. I'm Amelia. Along with my group members Kobe Hong, Maidili, and Vishalini will be presenting for today's presentation. The topic of our presentation is soil monitoring system in palm oil farming industry in Malaysia. I will now briefly explain on the abstract of our assignment. Malaysia is the second largest producer of palm oil, is facing a potential economic repercussion from the EU's proposed import ban driven by environmental concern. To enhance sustainability, the implementation of advanced soil monitoring system is proposed, utilizing sensors to track soil condition and optimizing irrigation. This approach can help Malaysia demonstrate its commitment to sustainable practice and also to improve the quality of palm oil production. Next, I will explain on the introduction of our assignment. The global population is projected to reach 10 billion by 2050, necessitating sustainable agriculture practices, particularly in Malaysia's palm oil industry, which has expanded from 55,000 hectares in 1960s to over 5.9 million hectares today. To modernize farming, the Malaysian government supports IoT adoption, amplifying by the soil monitoring system in palm oil farming project. This technology replaced traditional methods with automated data-driven approach, addressing challenges like potential EU import bans and labor shortage, which causes the industry RM 7.9 billion annually. IoT enables real-time monitoring and also optimizing resources management, fostering sustainable practice and enhancing productivity while integrating with other smart agriculture techniques. Ultimately, IoT-driven solutions aim to ensure the resilience and also the future availability of Malaysia's agriculture sector. Next, I will discuss on the study method of the case study. So I have compiled 10 case studies that has helped me in order to further understand the IoT implementation for soil monitoring system in a palm oil. So the first case study, it is palm oil soil monitoring system for smart agriculture. Secondly, economic feasibility and water footprint analysis from smart irrigation system in palm oil industry. Third, smart farming, Internet of Things, IoT-based sustainable agriculture. Fourth, Internet of Things, IoT for smart precision agriculture and farming in rural areas. Fifth, smart irrigation system for precision agriculture. Sixth, leveraging Rover-1 technology for smart agriculture monitoring for palm oil plantation. Six, IoT soil monitoring based on roller module for oil palm plantation. Eight, Oregon network-based system for remote monitoring for agriculture called SMART. 9. Agriculture system using IoT technology development for oil palm precision. And also lastly, agriculture smart management in oil palm seedling nursery. Next, I will explain on the common hardware and software. A review of case study in smart farming reveals key technologies such as sensor and also actuator for monitoring crops condition, soil pH, moisture, and also environmental factor. This sensor collects real-time data sent to cloud system to analysis, enable automated pest control, facilitation, and also irrigation. Wireless technology like GSM, GPRS, Wi-Fi, and LoRaWAN facilitates remote monitoring, while advanced tools like drone, LiDAR, and also AI refine practices. Focus on sustainability. This technology optimize resources using and minimize environmental impact, making them versatile for implementation of soil monitoring system in Malaysia palm oil industry.
Good day everyone, I'm Kobe Hong and I will discuss about the advantages and disadvantages of the case study mentioned previously. Firstly, for palm oil soil monitoring system for smart agriculture, it will bring benefit as it is a real-time monitoring which helps soil assessment efficiently. However, it relies on internet connectivity and brings data security concern. Next, for the second case study, it focuses on sustainability and resources, which generates comprehensive economic analysis. Nevertheless, it requires detailed financial data and may be challenging to implement in diverse plantation settings. For smart farming, it helps to enhance productivity and sustainability and reduce labor intensity. However, this will exclude biotechnology and livestock production and require significant technological infrastructure. Next, smart precision agriculture and farming in rural areas can improve connectivity in rural areas and reduce network latency. Even so, the network setup is complex and the implementation costs will be expensive. Furthermore, smart irrigation systems for precision agriculture have diverse applications in different environments and facilitate remote monitoring and control. Despite that, the implementation is complex and the maintenance cost is high. For the LoRaWAN technology, it is a precise agriculture method and it optimizes resource utilization. The bad thing about LoRaWAN is it needs high initial investment and the integration system is complex. Next, soil monitoring based on LoRa module can enhance productivity and sustainability and further reduce labor intensity. However, this will exclude biotechnology livestock production and require significant technological infrastructure. Moreover, LoRa network-based system for remote control promotes environmental sustainability and support resource conservation. This system may need extensive farmer education and the implementation cost is high. By using IoT technologies in smart agriculture systems, it will improve the connectivity in rural areas and reduce network latency. However, the setup of the network is complex and the implementation cost is high. Lastly, smart management in oil palm seedling nursery. It can't be denied that this is a comprehensive monitoring and cost-effective mapping solution. Even so, the tropical weather conditions can affect accuracy and the high technology will lead to high costs. Now I will talk about the technical design of our case study. The soil monitoring system will be installed on a Malaysian palm oil plantation using WAPS mod sensor platforms. Sensor will be measure soil moisture, temperature, pH, and humidity on these platforms, providing essential soil management data. The sensor platform will connect to the EasyFarm platform via a GPRS shell or Mycelium IoT gateway for reliable field to central system data transmission. Farmers will use a mobile app or web interface to access the EasyFarm platform for real-time soil and environmental data. The platform will generate irrigation schedules based on data, helping the farmer to save water and increase palm oil production. Next, the methodology of the case study. Felda, Simdabi, and Felkar operate Malaysian oil palm plantation with scheduled manual irrigation and fertilization. Traditional methods are laborious and ignore nutrients and waters. Smart irrigation improves precision and efficiency. To maximize water and nutrient use, the system would monitor soil moisture and nutrient levels and adjust irrigation and fertilization. Real-time data ensure oil plants receive enough resources, reducing waste and increasing yield. A smart irrigation system viability must be determined before implementation. System hardware and software are assessed. This improvement will help large plantations manage resources, and the technical design will include selecting the sensors to measure soil moisture, temperature, pH, and nutrient level and integrating them with data processing and communication technologies. Advancement and customized solutions in the smart irrigation system improve Malaysian palm oil farming. Now we will move to hardware used in the case study. Firstly, pH sensors. pH sensors monitor the soil acidity or alkalinity, maintaining the soil pH within the optimal range for oil palm cultivation. Secondly, nutrient sensors. These sensors measure level of nitrogen, phosphorus, and potassium in the soil, allowing to the optimization of fertilization schedules. Thirdly, drones for monitoring. Drones provide area surveillance of the plantation, helping to detect issues such as pest infestations, diseases, and growth irregularities early. Next, water flow sensors. Water flow sensors track the rate of the water used in irrigation, aiding in the monitoring of water usage and the promoting efficient irrigation practices. This helps to avoid water wastage and minimize the environmental impact associated with excessive water use. These sensors measures the water content in the soil, providing crucial data for determining the precise irrigation needs of the oil palm trees. Next, we have weather station. The weather station provides real-time data on temperature, humidity, rainfall, and wind speed. This information is essential for adjusting irrigation to schedules to match weather conditions, ensuring that water and other resources are applied efficiently. Moreover, IoT Gateway. The IoT Gateway acts as a central hub for collecting data from all sensors and transmitting it to the cloud for analysis. This facilitates real-time monitoring and control of the plantation, enabling timely interventions and data-driven decision-making. Lastly, automated irrigation system. The system automates the irrigation process based on the data from soil moisture sensors and weather stations. Now we will move to the software used by our case study. Firstly, REST API for cloud computing. REST API enable integration with other software and systems, ensuring seamless communication between different components of the IoT system. Next, data analytics software. This software analyzes the collected data to generate actionable insights, optimizing irrigation and fertilization schedules. It helps predict plantation management by facilitating data-driven decisions. Furthermore, dashboard and visualization. These tools provide visual representation of the collected data, making it easier for plantation managers to monitor key metrics, track performance, and identify trends of anomalies. Moreover, IoT platform. The IoT platform collects, stores, and processes data from all connected sensors and devices. It offers a centralized solution for real-time monitoring and data analysis, enabling informed decision-making and supporting long-term improvement by providing comprehensive data insights. Lastly, automation software. Automation software supports the automation of various processes such as irrigation and fertilization. By reducing manual labor and ensuring consistent resource application, it enhances operational efficiency and productivity.
Good day, madam. My name is Vishali Nandakumar and I'll be continuing the presentation from the proposed method. The palm oil industry is a crucial sector in Malaysia's economy, being one of the largest producers and exporters of palm oil globally. However, with increasing environmental concerns and a growing demand for sustainable agriculture practices, soil monitoring has become essential for the efficient management of palm oil plantations. A well-developed soil monitoring system is necessary to ensure optimal crop yields, maintain soil health, and minimize the negative environmental impact. And various proposed methods in soil monitoring for the palm oil industry have been developed and explored, focusing on the technology-driven and data-oriented approaches. So the first method will be sensor-based monitoring technologies. Secondly, remote sensing and geographic information systems. And also the third will be soil sampling and laboratory testing. And fourth, data analytics and artificial intelligence. Next, let us dive into the system implementation overview. The first step in implementing a soil monitoring system is establishing the necessary infrastructure and hardware across the plantation. This involves sensor installation, communication network, power supply, and drone or satellite deployment for remote sensing. Once the hardware is in place, the next step is to integrating the sensors and remote sensing data into the centralized IoT platform. This platform functions as a central hub where all the data is collected from the sensors, remote sensing devices, and soil sampling is gathered, processed, and stored. The key steps include device connectivity, platform customization, and automated alerts. Once the sensors and devices are operational, the system begins collecting data continuously. Effective data management is essential to ensure that the data is accurate, secure, and actionable. And this involves real-time data collection, data storage, and data security. Next, to successfully implement a soil monitoring system in palm oil plantations, the process involves a series of detailed methods that covers everything from the selection of suitable hardware and sensors to the analysis and integration of data. Below are the critical components in the soil monitoring system, from the hardware setup to the data processing and automation stages. This involves the sensor selection and placement. Next is the communication network setup, and third is the IoT platform integration. Now, moving on with the results, one of the most significant outcomes of implementing a soil monitoring system is the improvement in crop yield and the overall plantation productivity. Next is by the resource and optimization and cost-effective efficiency, where the efficient use of resources such as water, fertilizers, and labor leading to a significant cost savings for plantation owners. And the third one will be the improved environmental sustainability. Next, for the output and performances, the first one is the increase in the palm oil yield. Secondly, the cost saving and return on the investment, which is the ROI. And last but not least is the operational efficiency and decision making. Now let's move on with the benefits for the implementation of proposed project. The implementation of soil monitoring system in palm oil farming presents a wide array of benefits that enhance productivity, sustainability, and overall management efficiencies. So these benefits includes increased crop yields, cost savings, and also enhanced resource management. So for the business model, by creating a business model for a soil monitoring system tailored for the palm oil industry involves several key components, which includes value propositions, customer segments, and revenue streams. While implementing the soil monitoring system in palm oil farming offers numerous benefits, it also comes with potential risks and threats that need to be carefully considered. So by identifying this risk allows plantation managers and technology providers to develop strategies to mitigate them effectively. So the risks that may be involved are as follows, which is technical risk, financial risks, and also operational risk. For the counter-intuitive solutions, the implementing in soil monitoring systems in palm oil farming presents opportunities for innovation, but sometimes the best solutions are not immediately obvious. Here are some counter-intuitive approaches that could enhance the effectiveness and adoption of these systems. The first one would be emphasizing traditional knowledge. Second, inverting the focus on efficiency. And third is by encouraging low-tech solutions. So that is all from me. I would like to pass the floor to the next presenter. Thank you very much.
Good day everyone, my name is Maitri Nagalingam and today I would like to explain on the future prospect of the soil monitoring system. We see tremendous potential for this revolutionizing the palm oil industry in Malaysia. On the part of innovative aspect, our system leverages IoT technology by integrating smart sensors across plantation. These sensors monitor critical soil parameters such as moisture, pH and temperature in real time. The data collected enables farmers to make informed decisions, optimize irrigation schedule and boost crop health. For example, using real-time data, farmers can avoid over-irrigation, which is a common issue in traditional methods. By applying water only when needed, this system not only conserves water but also improves crop yields and reduces nutrient runoff. In fact, similar systems in other plantations have already shown a 30% reduction in water usage. This innovation brings significant cost saving and ensures sustainable farming practices. The system is scalable and can be tailored to different plantation and sizes, making it accessible to both large corporate farms and smaller family-run operations. By promoting inclusivity, we aim to extend the benefit of advanced technology and all palm oil farmers. On the part of Sustainable Development Goals, SDGC achieve, this project aligns with multiple UN Sustainable Development Goals. First, SDG 2, Zero Hunger, focuses on improving food security by increasing agriculture productivity. Our system contributes to this goal by enhancing crop yields through optimized irrigation. Additionally, SDG 6, Clean Water and Sanitization. It addresses as the system prevents water waste and reduces pollution through precise water management. Finally, SDG 12, Responsible Consumption and Production, is fulfilled by promoting sustainable palm oil farming practices that minimize waste and environmental impact. The innovative aspect of this system and its alignment with global sustainability goals demonstrate its transformative potential in the oil palm industry. To conclude our presentation, the soil monitoring system represents a significant leap forward for Malaysia's palm oil industry. By integrating IoT technology, this system allows farmers to move from traditional methods to data-driven automated processes. The benefits are clear: improved productivity, efficient resources management, and reduction in environmental impacts. Malaysia faces increasing scrutiny from international markets regarding its palm oil production, particularly with regard to sustainability. By adopting this system, Malaysia can enhance its global reputation as a leader in sustainable palm oil farming. This will help maintain competitiveness in markets that demand ethically produced palm oil, especially in the European Union. Additionally, the project not only improves agriculture efficiency but also supports broader sustainability efforts. The adoption of IoT in agriculture is not just an innovation, but it is a necessity in the world where resources are becoming scarcer. This system ensures that Malaysia's palm oil industry can continue to thrive in an environmentally responsible way for future generations. To sum up, our soil monitoring system is a forward-looking solution designed to secure the sustainability and viability of the palm oil sector. It promises long-term benefit both economically and environmentally, making it an investment in the future of agriculture. That's the end of our presentation. Thank you.